Hello everyone and welcome to section 3.2, Measures of Center. In this section we're going to look at what the characteristics of the center of a data set look like. And that is going to include learning topics such as means and medians as tools for analyzing data. The goal here is not only to determine the value of each measure of center, but to interpret what they mean. And as we'll see, each of them has different strengths and weaknesses. And depending on what you're trying to look at for your data, either a mean or a median may be appropriate. So the basic concept here is measures of center. And what we're really after is the value that's at the center or middle of the data set. And as we'll see, there's different ways of skinning that cat. However, the goal is to understand something about the center of our data as opposed to any other aspect of the data. So the first way and the most common way that we look at the center of a data is through a mean. And a mean is the same thing as an average. And how you calculate this is you're going to obtain all the values in your data set. You're going to add them all together, and then you're going to divide by the total number of values that you had. And again, this is called an average. So a couple of notations that we need to understand. This symbol here denotes the sum of a set of values. X is the variable, and it's usually used to represent the individual data values. N represents the number of data values in a sample. And uppercase N, if we were using it, would represent the number of data values in a population. However, as we've discussed a few times before, this is mostly a course in samples. So we'll show you how to do it in populations, but for the most part, we're going to focus on the equations for samples. Okay, so based on what we talked about for a mean, this is actually the equation. And this symbol here, X bar, actually denotes the mean of a sample. Okay, so what do we have here? X bar, or the mean, equals the sum of the x's, so adding all of the data values together, divided by the number of total data values. This equation down here is how you would do it for a population. I'm not going to spend a lot of time on that. However, it would function the exact same way, just the symbols are slightly different. Okay, so what are the advantages of a mean? The sample means are drawn from the same population tend to vary less than other measures of center. So what that means is that if you were to take, say, a large population and you had multiple sample sets from that, and you were to calculate means, you would find that there is very little variation between the means, regardless of which sample you took the mean from. And one of the reasons that is it takes every data value into account. Each one gets added into the equation, and so each one is represented in a way. On the flip side of that, the disadvantage to that is that it's very sensitive to every data value. So if you have an extreme value in one way or the other, it can actually drastically impact your mean. So it's not, we don't call a mean a resistant measure of center in the sense that it can hold up to that. It is very sensitive, and so sometimes you may choose to exclude data that doesn't fit within your data set, either data that's very, very low or very, very high, and is just doesn't fit the general trend of the data that you've been looking at, to avoid this issue, and we'll talk about that in further in later chapters within the course. Okay, so let's do an example here. And this is from the textbook, so you can actually find this table in the text. It's table 3.1. But what they've done here is they've looked at counts of chocolate chips in different cookies. So you can imagine that for Chips Ahoy, that they want to have a similar amount of chocolate chips per cookie because they want the customer experience to be the same, regardless if they bought one box of cookies or 2 boxes of cookies. So, okay, so the mean of the first 5 counts of chocolate chip cookies, here we go. So the first cookie had 22 chips, second cookie also had 22 chips, Third cookie had 26 chips, fourth cookie had 24, and the last cookie had 23 chips. Okay, so based on all of this, let's calculate a mean. So we're going to add all of these data values together, and then we're going to divide by the total number of data values, which we already know is 5. Okay, so using our equation, we've plugged in each of the data values, 22 chocolate chips, 22, 26, 24, 23. We've added them all together to get 117, and we've divided by the total number of counts that we did, 5. And what we find out is we have a mean number of chocolate chips of 23.4 chips. What you'll notice is that it's the in-between. So for example, the cookie with 22 chocolate chips is a little low, the cookie with 26 chocolate chips is a little high, but when you average it out, it's 23.4 chips. Okay, so now that we've talked about means, let's talk about medians. Median is another way of looking at, it's another measure of center. However, it has different properties and is used in a slightly different way. So a median by definition is the middle value when all of your original data values are arranged in order. They can either be ascending or descending. It doesn't really matter. The symbol for a median is this X tilde. But you won't use the symbol very often, but just throwing that out there for you. And the median is interesting because it's not affected by an extreme value. So it is a resistant measure of center in comparison with the mean. Doesn't mean necessarily that it's a better measure of center. It's just talking about its resistance to being affected by extreme values one way or the other. Okay, so how do we find a mean? First, we're going to sort all of our values and arrange them in order. Then, if the number of data values is odd, the median is the number located in the exact middle. If the number of data values is even, then the median is found by taking the mean of the two middle numbers. So let's look at what that actually means. Here's our data set right here in raw form. Now we're going to put it in order from low to high, what they've done here. Okay? So this data set has an odd number of values. So it's just the middle value is our median, 0.73. So again, the odd number of values, it's always just the middle value here. However, in this other data set that they've given us, it's very similar, except here they've given us an even number. We're going to sort them in order, and what we're going to find is that we actually have two middle values, 0.73 and 1.1. So there's no exact middle. The middle is actually shared by these two values. So to calculate the median, we're going to add those two values together, 0.73 plus 1.1, and we're going to divide by 2. So essentially we're taking an average of those two. And we will find that our median is 0.915. Okay, so now that we've talked about means and we've talked about medians, let's talk about a mode. Mode is another measure of center, and by definition, a mode is the value that occurs with the greatest frequency in our data set. The data can have one mode, it could have more than one mode, or it could have no modes. And these are some definitions that go along with that. If it has two modes, we consider it to be bimodal. If it has more than two, it's considered multimodal. And if it has no data value repeated, then it has no mode. Okay, so here we go. Here is an example of modes. So let's look through this. Again, we're looking for the data value that occurs with the greatest frequency within the data set. Okay, so in A, we'll say that 1.1 is the only data value that's repeated more than once. And so our mode in that case would be 1.1 because it's the data value that occurs with the greatest frequency in that data set. All right, moving down to B, we have 27, which is repeated 3 times, 55, which is repeated 3 times, and 88, which is repeated twice. Now you may be tempted to call this, say that this has 3 modes. But in reality, keep in mind the definition of a mode. It's the value that occurs with the greatest frequency. So even though 88 is repeated twice, it's not as great of a repeat as 55, which is repeated 3 times, and 27, which is repeated 3 times. So in this case, 27 and 55 are our two modes. So this would be an example of a bimodal. Okay, and then let's look at sample C. Sample data C, there's no values repeated. So this has no mode. And it's not a bad thing if something doesn't have a mode. It just means that there's no data value that's repeated more than once. Okay, a couple of other things we want to get through in this section. Mid-range. Mid-range is the value midway between the maximum and the minimum values in the original data set. So there's a simple equation for calculating this. To calculate the mid-range, you'll take your maximum value in your data set, you'll add it to the minimum value in your data set, and you'll divide by 2. And that'll give you your mid-range. Okay, a couple of things about mid-ranges. It is sensitive to extremes because it only uses the maximum and minimum values. And for that reason, it's rarely used. So although you're learning the way to calculate it here, it's not something that we're going to use in a practical sense either within the course as well as in everyday life. The redeeming features, however, of a mid-range is obviously it's very easy to compute. You're just taking your max, adding it to your min, and dividing it by 2. It reinforces that there are several ways to define center, and it avoids confusion with the median by defining the mid-range along with the median. So again, mid-range is not something you're going to use very often, so I don't want to spend a ton of time on it, but it is another measure of center, and it does allude to the fact that there's different ways to skin a cat. That when you talk about the center of the data, none of these are wrong. Mid-range is an appropriate way to do that, your median is, and your mean is. It's just talking through which is, for practical purposes, the best way to go about doing this. And for the most part, people use the mean more than anything else. Okay, when you're looking at data, you want to look at your results and think about whether they're reasonable. And you want to think about the method that's used to collect the data. So for an example here, we want to identify the reason why the mean or median would not be a meaningful statistic in these different examples. So in A here, we have the rank by sales of selected statistics textbooks. You can see we have 1, 4, 3, 2, 15. Now, a median here, it would tell us the center of the data. So in this case, hold on. In this case here, we have an odd number of values. So if we put these in ascending order, we'd find that that 3 would be our center value. But it's really not that meaningful given that we're looking at rank of sales by selected statistics textbooks. Looking at example B here, the number of jerseys of the starting offense from the New Orleans Saints when they last won the Super Bowl. Okay, so here's all the numbers that were on the jerseys, but is it helpful to calculate a mean or a median? Probably not, just given the subject matter. And so as you're looking at problems, you need to ask yourself whether the answer that you're actually getting out is helpful or not, and whether the different ways that you're looking at describing your data, the mean or the median, are they helpful or not? And in either of these examples, they happen not to be. So you do want to use your common sense when looking at these things. Okay, so in the second half here, we're going to look at kind of the beyond the basics of the measures of center and talk through a couple of other things. We're going to move pretty briskly through this section because the real crux of the material for this section we learned in the first part, which is the means, the medians, and the modes. And here we're going to introduce a couple of other things. Okay, you can also calculate a mean from a frequency distribution. So in Chapter 2, we learned how to make a frequency distribution or a frequency table. And we learned how to develop classes and how to put the frequencies within that. And you can actually use those tables to calculate the means for the entire table. So it's an easy way of calculating out a mean for a large group of data. And here's the formula that you would use for that. So you have the sum of f times x, which is your frequency times your x's, divided by sum of your frequencies. Okay, so let's take a look at that. So here is your IQ score table from Chapter 2. You can see each of the classes is listed just in the same way that it was before. You can see that our frequencies of our data is also listed here. And they've also summed it for us. They've added it up together. So there were 78 frequencies. They've also put class midpoint here. Now we learned how to calculate class midpoint in Chapter 2. It's the center of our class. So they've added that into the table. So you can see that that midpoint then is the x in our equation. So if we multiply across the table the frequency times our midpoint, or our f times our x, we can get a value over here. And when we look at the equation that we're going to be using, which needs f times x to solve, it's actually going to give us that number. So if we go through and we do our f times x for each class, we get a number. Then we can actually add them all together here to get our sum of f times x that we're going to need for our equation. So now we have our sum of x, f times x, and we have our sum of f, which is exactly what we need to solve. So we'll plug those into the equation. So 7201 divided by 78. And we'll find that our mean for our frequency table is 92.3, which is located somewhere within this middle class. So that actually makes sense when we look at our data. Okay, a couple of other things, but like I said, we're not going to spend a ton of time on these. You can also calculate what's called a weighted mean. So this is when data values are assigned different weights, and those weights are represented by the symbol W. And you can compute a weighted mean. One of the types of weighted means that typically gets used is in calculating grades. So let's look at this example. In her first semester of college, a student of the author took 5 courses. Her final grades, along with the number of credits, were: she earned an A in a 3-credit course, an A in a 4-credit course, a B in a 3-credit course, a C in a 3-credit course, and an F as a 1-credit course. And the grading system is going to assign points to the letter grades. So an A is going to be worth 4 points, a B is going to be worth 3 points, a C is worth 2, a D is worth 1, and an F is worth 0. And we want to actually compute her grade point average based on these courses. So we're going to use the number of credits as the weights. So you'll see that there was a weight of 3 credits, 4 credits, 3, 3, and 1. And we're going to replace the letter grades of A, B, C, and F with the corresponding quality points: 4, 4, 3, 2, and 0. And so when we actually calculate this out, we can plug all of these into the equations and find that she actually had a GPA for the semester of 3.07. So if you were ever interested in calculating your own GPA, this is how you would go about doing it. However, weighted means aren't used all that often. Grades just happen to be a good example of it. Okay, and that's going to end section 3.2 on measures of center. Up next, section 3.3 on measures of variation.